Hi Precalc, this is Mr. Gamboa. I'm going over the Practice A exam. So this time when you guys take your exam, you'll see the time breakdown. It's a suggested time breakdown. You overall have 30 minutes for the exam on Friday, or for anyone else watching this whenever you end up taking it. Let's do it. So question 1 is, we have y equals 3x squared minus 6x plus 10, and we want to be able to figure out what are the coordinates of the vertex. So for part A, what we do is we do what's called the line of symmetry equation. X equals negative b over 2a, and we fill that in. So the negative b part is talking about, this is b, so we're going to write negative 6, cool, over 2 times a. A is the first number in front of the x squared, so it's times 3. So this simplifies to negative 6, so regular 6, over 2 times 3, which is 6. So I get a 1. So the x coordinate of my vertex is 1. To find the y coordinate, what we're going to do now is we're going to take that 1 and plug it into the equation. So at the same time, we're going to write y equals 3 times 1 squared minus 6 times 1 plus 10. Okay, so doing our math, we're like, that's basically 3 minus 6 plus 10, and that's basically negative 3 plus 10, that's 7. Okay, so for part A, we would say the coordinates of our vertex are 1, 7. Okay, so that's done, and that earns you 3 points. Zoom in on the video if you need to see a bit closer. All right, for part B, what are the coordinates of the y-intercept? We remember that a y-intercept is the part of the graph that touches the y-axis. So the thing that's always true about that is that we have a x-coordinate of 0 anytime we're talking about a y-intercept. So we're going to take that 0 and we're going to plug it into the equation to get the y-coordinate. So we would create this. Y equals 3 times 0 squared minus 6 times 0 plus 10. And that's obviously going to give us 10 because all the zeros would cancel each other out. So the coordinates to the y-intercept are 0, 10. Okay, that's part B. Last but not least, sketch a rough graph of your quadratic function using the vertex, the y-intercept, and one other point. So for that one, let's switch to orange. You would basically want to draw your x-axis. Let's plot the 2 points. We have 1, 7. So let's pretend this is 1 and here's 7, right? So here's that point. We have our y-intercept, which is 0, positive 10. So that would be a little higher. Here's 10, right? So 0, positive 10. So we have this point, orange point, we have that point there. And then since I know this is my vertex, right? The 1, 7, right? For my quadratic, remember my u's either look like this or they go upside down. I asked myself, is this u opening up or down? And I look at the first number of the quadratic, the x squared, it's a positive 3. So I know it's opening up. It looks like that first picture. So I would connect this going up like that, and it's got to go the other direction as well, okay? The other way. Now, to figure out that one extra point, we'll use the symmetry argument. We're saying, if this is 0, 10, and that's 1, 7, let me do that in maybe a different color, like green. We say to ourselves, well, from 0 to 1, that's a distance of 1, right? From 0 to 1, right? We only took one step this way. So this other point on the other end is also 1 away. So if I know there's a point at 0, 10, that must mean that there's also a point at, in this case, 2, 10, okay? Because it's a mirror image from the middle there. So 2, 10 is another point. All right, that answers question 1. And that should have took around 5 minutes. Moving on to the next part. All right, for part B, we ask ourselves, okay, what is the coordinates of the vertex now? In problem 2a, we simply switch that number to positive 3, and then we keep the 2 as positive 2. Okay, easy as that. Actually, it should save you less time. That shouldn't even take less than 30 seconds. What are the coordinates of the y-intercept? Again, a y-intercept always has an x-coordinate of 0, right? Anytime you draw your picture for your u's, a y-intercept has a y-coordinate of 0. But what's the other number? Take the 0, plug it in. Let's do that here on the side. Y equals 8 times 0 minus 3 squared plus 2. So that's 8 times negative 3 squared plus 2. 8 times 9, because negative 3 squared is negative 3 times negative 3, that's positive 9, plus 2. So that's 72 plus 2, that's 74. So 0, comma 74 is the coordinates of my y-intercept. So I've done these two. Last but not least, sketch a rough graph of your quadratic using the vertex, the y-intercept, and one other point. So just like before, on the side here, you can draw a picture. Let's put 3, comma 2. 1, 2, 3, up 2. Here's our point. And then we have this 0, comma 74. So it's really high up there. Like let's just pretend that's 74. It's way up here. There's another point. Okay. So again, when we look at this equation, how do I know if it's the u that goes up or if it's a u that travels down like that? Question, right? Again, I look at that first number here. Since it's positive, I know that 8 is gonna make the u go up. Positive values make the quadratic go up this way. So I know therefore, if this is my vertex, my 3, comma 2, the picture should look like this. U goes this way, u goes that way. Okay? And like before, I do the same kind of thinking as before. Let me switch to orange here. From our y-intercept to the middle, right, to where that vertex is, it looks like I took 3 steps, right? Because this y-intercept is 0, comma 74. Right? So I take 3 steps from 0 to 3. Therefore, I got to take another 3 steps this way. And that means this point up here is at that same height at 74, but its x-coordinate is 3 steps from the middle, which is at 3, so now it's at 6. Right? We would say that one is at 6, comma 74 for that problem. Okay, so that would be a good graph there. 0, comma 74, 6, comma 74, 3, comma 2. Okay, I think I took a little bit longer in explaining it, but that also should have taken around 5 minutes. Last but not least, we have it in factored form. Let's answer all these questions. What are the coordinates of the vertex? Well, what I do here in this situation is I kind of have an idea of where I'm crossing the x-axis. I switch these numbers. Remember, anytime I go from equation to graph, the opposite of -2 is +2, and the opposite of -5 is +5. So I know my u goes through these points like this, or it could be doing this, depending if it goes up or down, right? Upon inspection, I see that the first number is +4, so it's gonna open up. It's gonna look like this first picture that I drew. Okay, so to find the vertex, I know it's gonna be a low point. How do I figure it out? Well, again, I've always been taking advantage of this line of symmetry idea, right? This should be perfectly cut. So I have to ask myself, what is the halfway point between 2 and 5? Like, what number is exactly halfway between 2 and 5? To answer that question, all we do is we simply find the midpoint. We do 2 plus 5 and cut that in half. Luckily for us, 2 plus 5 is 7, and 7 divided by 2 is 3.5, right? So I know the x-coordinate of this u is 3.5, because that's halfway between my two x-intercepts, right? And how do I figure out the y-coordinate? Well, I'm going to take that 3.5 and I'm going to plug it into the equation. Okay, let's do that work here on the side. What is 4 times 3.5 minus 2 times 3.5 minus 5? Well, that becomes 4 times 3.5 minus 2 is, I believe, $1.50. And then 3.5 minus 5, I believe, is negative $1.50. Okay, so we'd simply figure out what is 4 times 1.5? I think that's 6. And then what is 6 times negative 1.5? I believe that's negative 9, I believe there. Okay, so it turns out the y-coordinate is minus 9. Okay, so that answers question 1. What's the coordinate to the vertex? It's 3.5 comma negative 9. Again, the way we found the x-coordinate is the x-coordinate of the vertex is it's the halfway point between the line of symmetry. So we found the midpoint between 2 and 5. You find that by adding the numbers together, dividing it in half, and then taking that number, plugging it into the equation. All right, for part B, we know that's pretty easy. For part B, what's the coordinates of the y-intercept? By now we should know that we're just basically plugging in 0, right? 0, and then see what happens when we do that. The cool thing about plugging in 0 is when I plug in 0, basically I'm just doing 4 times negative 2 times negative 5, because the zeros just don't really contribute anything, right? So in our mind's eye, 4 times negative 2 is negative 8. Negative 8 times negative 5 is 40. Okay, so 0, 40 is the coordinates of the y-intercept. Okay, last but not least, same question as before, sketch a rough graph. So we kind of already have a rough graph here going. We have the vertex, we now know that the y-intercept at some point is going to be 0, 40, right? That's where it crosses the y-intercept. So you can draw you kind of like doing that. And so by using that same symmetry argument, notice that the y-intercept is 3.5 from the middle. So if I go 3.5 away, I know that I'm going to end up at 7, 40 as another point, okay? Because both are, in this case, 3.5 units away from the center. Okay, 3.5 plus 3.5, that's where I got the 7, right? And then the 40 is because it's the same height as the y-intercept. That would be a rough sketch that I could use, okay? So overall, that should have taken around 15 minutes. At the time of recording, it looks like it's only been about 10 minutes and 50 seconds. So again, that was going at nice slow Gamboa pace. Give yourself some extra time, obviously. Let's go to the backside. Okay, the backside of the test should go a bit quicker because it's less intensive. You don't got to draw so much, except for this next question. Question 4. For the quadratic function x squared plus 6x minus 41, rewrite this in vertex form using the completing the square method. You must draw some semblance of the diagram that we went over in class. And then at the end of it, just tell me the coordinates of the vertex, because again, that's the whole point of doing it. Let's get to it. So when I'm completing the square, remember, take the x squared, draw a square. Its dimensions would be x by x, because x times x is x squared. What do I do with the 6x? It needs to get evenly split. If I'm going to split 6 x's, that's going to be 1x rectangle, 2x rectangle, 3x rectangle going this way, 1, 2, 3x rectangles going that way. That splits up the original 6x, 3 this way, 3 that way. And again, what that would create is in the middle, a bunch of 1 by 1 squares. How many in particular? Well, when we draw our picture, it looks like we would end up making 9, right? So again, what's the dimensions of this big square that we made? It's x by 1, 1, 1, so plus 3, right? Because each one of these rectangles has like a width of 1. And same case going down this dimension, right? This is x, and all of these are 1, 1, 1, so this is x plus 3 going that way, okay? So again, from the picture, we see that x plus 3 times x plus 3, aka x plus 3 squared, gives me a total area of 1x squared, 1, 2, 3, 4, 5, 6, 6 x's, right? And then a total collection of about 9 single ones, right? So at that step, if this is all you were able to do on your exam FYI, this is out of 6 points, I would give you a point for having built your diagram. I would give you a point for having labeled this equation, right? At this point, I would say I would give you about probably 3 points, like half the points. How do I get the rest of the points? So the idea now is when I compare back to the original equation, in the original equation, I want to end up subtracting 41. But based off my diagram, I'm adding 9. So remember, the idea is I have to think to myself, what do I have to add or subtract from both sides of this equation to end up with a minus 49 instead of a plus 9? Think of it as credit card debt or money. You have $9 in your bank account. So what did you buy to end up having negative $41 in your bank account at the end? Doing some simple math, we would say, well, I need to go from $9 to 0, and then I need to spend $41 to get it to negative 41. So altogether, I must have spent about 50 bucks, right? So if I subtract 50 from both sides of this equation, I would create the new equivalent equation reading x plus 3 squared minus 50 is the same thing as x squared plus 6x, and then again, 9 minus 50 is minus 41. Okay, so there we go. So we were able to rewrite our original quadratic in vertex form. We recognize the vertex form because it's always x plus or x minus something squared and then plus some number or minus some number. In this form, I can see the coordinates of the vertex are negative 3 comma minus 50. Remember, we switch the number inside of the x plus or x minus squared thing, and then we keep the number afterwards. That's just simply the y coordinate, okay? So that is how we would do something like question 4. All right, moving on. Question 5. Here we have a polynomial. It's in factored form. Let's get through the questions. Question 1, determine the x-intercepts. Easy. The x-intercepts show up in the factors here. And I see 3 factors. There's an x plus 1. So the x-intercept there is the opposite of the number there. So I would simply write minus 1. Okay. in the graph, it's going to cross through -1. If I look at the next part, I have an x minus 2, so I know it's going to cross it at regular 2. I switch this value. That's another x-intercept. Last but not least, I see an x minus 2.5, so I know it's going to cross, or in this case, bounce off of the graph at 2.5, okay? All right, you don't have to write down bounces or passes. That was just for that one lesson. All I'm looking for part A is these numbers, right? We just literally switch the values. Part B, write the multiplicities of each factor. Well, for the very first factor, multiplicity means how many times does that factor show up? What's the exponent, if any, on the number? X plus 1 has multiplicity 1. Okay. What about x minus 2? What's the multiplicity of that? Upon inspection, you should say, that only shows up once, so it should be 1. Okay. And the multiplicity of the very last factor, x minus 2.5, since there's an exponent 2, that means there's really 2 copies of it. So its multiplicity is 2. Okay. That answers part B. Part C, determine the degree of the polynomial f of x. As we mentioned, right? The degree is the highest exponent in my polynomial once it's all multiplied out. So instead of multiplying all that out, we simply add the multiplicities. This has multiplicity 1, that has multiplicity 1, and this is multiplicity 2. So I add these numbers to create 4. Okay. Degree 4. Part D. Determine the coordinates of the y-intercept. By now we know y-intercepts have an x-coordinate of 0 and a y-coordinate of whatever we get by plugging in 0. So let's do some quick mental math. If I plug in a 0 here, I'm basically doing what? 2 times 1 times -2 times 2.5 quantity squared. Okay? 2 times 1 times -2, that's a -4. 2.5 squared, I believe, is 525. Let me write that here. 525. And then multiplying these all together, I believe would give me -21 at the end. So I'm going to write that there. Okay? Again, obviously, I'm trying to do this mentally in my head. Use a calculator. If you catch the mistake on this video and you want to tell me about it, tell me later for some extra credit. Anyways, E. Determine the end behavior of f of x. Okay, so the important things when determining end behavior are, first and foremost, do I remember the sentence frame? And that's this. As x, this might be hard to read on the video, so I'm switching colors, sorry. As x goes to infinity, where does my graph go? My graph has a name, it's f of x. And as x goes to -infinity, where does my graph go? Okay, so here's where we got to remember our notes. What do we know the degree is? The degree is 4, right? 4 is an even number. And the leading coefficient, the number in front of everything, is going to be 2, which is positive. Okay? So thinking back to our notes, when it's positive and even, the end behavior we know is both going to go up. Okay? This polynomial, you know, it goes through -1, it goes through 2, it freaking bounces off of 2.5, right? So it has all of this business happening in the middle, but end behavior talks about what happens in the far lefts and far rights. So what we should be writing in here is, as x goes to infinity, as I go to the far right, the graph goes up, therefore I write infinity there. And then as x goes to -infinity, as I go this way, far left, where's the graph going? It's also going up, therefore I should put another infinity symbol in there. Okay? So that's end behavior, just writing those sentences. Okay, time check, it's about 18:47, and we're down to the last question, okay? So if you're going at the Gamboa pace, you're really good to go, because this last part is recommended 5 minutes. You're at the almost 19-minute mark, so you'd have some time to check your work at the end. Okay, last question. For the polynomial h of x, which is this monster here, oh my gosh, determine the remainder after division for x plus 1. So how do I do these again? What I don't want you doing is taking these factors and doing long division. If you want to do it, you're a bit of a masochist, you like pain, but let's do it the way that I taught you guys how to do in class. So for part A, what we said is, instead of plugging in 1, we're going to plug in the opposite of 1. We're going to figure out what is h of -1. We plug in the opposite for part A. Okay? So on your calculator, we would do 9 times -1 to the 5th power, just plugging in -1. We're subtracting 9 times -1 to the 4th power. We're subtracting 81 times -1 to the 3rd power. We're adding 45 times -1 squared. We're adding 144 times -1, and then we're subtracting 108 at the end. Okay, let's see if we can evaluate this. So negative 1 to the 5th power is just going to end up being negative 1 times negative 1 times negative 1 times negative 1 times negative 1, 5 times. It's going to end up being just one negative 1 left over, so that's going to contribute to making this first part just a negative 9. When I move on to the next part, negative 1 to the 4th power, that's negative times negative times negative times negative, which will end up being positive. So I'm really just still subtracting the 9 here, okay? This doesn't do anything. Next, I have negative 1 to the 3rd power. That's negative times negative times negative, which is negative at the end. So this is a negative 1 times a negative 81, so that's plus 81. We'll write that there. And then here we have plus 45 times negative 1 squared. But negative 1 squared is negative times negative, so it's positive. So it's really just adding 45, right? Last but not least, looks like I'd be subtracting 144 and subtracting 108, okay? So instead of doing the whole long division, we just have to figure out what this gives us, okay? So at that point, let me see if I can combine positive numbers and negative numbers. Negative 9 and negative 9 is negative 18. So 81 and 45 make 126. So I'm gonna write that here. This is 126 when I combine the positive numbers together. When I combine the negative numbers together, I end up subtracting 18 from that. And I'm still subtracting the 144, and I'm still subtracting the 108, okay? So give me a moment while Gamboa gets his calculator. Okay, so I would do 126 on my calculator. I would subtract 18, I would subtract 144, I would subtract 108, and end up getting negative 144 for part A. Oh my gosh. Oh my gosh, right? That's part A, right? So for part A, I would write negative 144. So when you're doing that on your test, make sure to just do it on a calculator or just on a separate sheet of paper. All right, so to do the next one, we're evaluating the remainder after dividing by x minus 1. So again, to do this one, to do part B, we take our same polynomial, but this time we're plugging in the opposite of minus 1, which is plus 1. So we've got to figure out what is h of positive 1. Doing that with y'all, that's going to be 9 times 1 to the 5th power minus 9 times 1 to the 4th minus 81 to the 1 to the 3rd power plus 45 to the 1 squared plus 144 times 1 minus 108. Okay. All right, so go ahead and do that. Notice that here, since it's all ones, nothing's going to happen. We're still just going to have 9 minus 81 plus 45 plus 144 minus 108. Okay, so let's see if that simplifies anything. The minus 9 is going to make it go away. So all I should be putting into my calculator is negative 81 plus 45 plus 144 minus 108. And if we did that correctly, we should end up with a remainder of 0. Okay, so this answer here is 0. Okay, so doing the same thing for problems C and D. At this point, if you're on your calculator, if you have it there, right, like the ones when you have your exam, you should just get straight to plugging in the numbers, okay? So I'm just not going to talk. I'm just going to work out the math, and then you can check your work in a bit as well. Okay, and so putting all that in the calculator gives me negative 104. Okay, the last division we should do is by plugging in negative 2. So we would say, what is h of negative 2? That is doing 9 times negative 2 to the 5th minus 9 times negative 2 to the 4th minus 81 times negative 2 to the 3rd plus 45 times negative 2 squared plus 144 times negative 2 minus 108. Okay. This one I actually had work out at the same time with the calculator by going back in and switching up all the numbers. This one actually ends up giving us a remainder of 0. Okay. So we get 2 zeros and 2 numbers that are both different there. Okay. So again, time check here. Just we can be honest with our time. It's been about 25 minutes. That would end the test at that point, because if you're doing this on your own and you went at the same pace I did, I would basically give you 5 minutes to check your work and make sure you get everything correctly. Okay. Again, 30 minutes is what you get, because that's working it out at the nice slow pace that I've been doing. There's an extra credit question there. My suggestion, if you're trying to do the extra credit for this question, is look at our examples that we've done for this one before. Okay, that's all I'll say. In our examples for this one before, we've said take this number, switch it to make a -3, plug it into the polynomial. We know that when we plug this in, the answer is the remainder, right? But this problem says that remainder is 0, so it's basically saying when you plug in -3, set that equal to 0. Okay, so our math would have to be 7 times -3 to the 3rd power plus 27 times -3 squared plus k times, again, -3 and then minus 27. Okay, so that's what plugging in -3 into the polynomial would create, and you're saying that's supposed to equal 0. Okay, so to solve that problem, you would simply work out what this is. You would just get a bunch of numbers and a single number of k, and you would solve for k like you would do algebraically. Okay, so I won't go over that. Y'all can do that on your own. There is a possibility, therefore, of getting 33 out of 30 points on your exam. But with that said, that is the practice exam A. Helpful video. Hope that helped in making sure you can study for your exam on Friday. Okay, good luck. Remember, no retakes, and you can do it. Bye.